Hello everyone, today I'm going to be showcasing my Minecraft Redstone integral and derivative calculator. So it's been a long time in the making. It took a while to build and debug, but it's finally done. And in this video I'm going to be going over how it works. So this includes the ALU, how it inputs the value, and the display unit. I'm also going to be going over what a derivative and integral is and how to calculate that, and how that applies to Minecraft Redstone, as well as the user interface. So I'm going to be going over this. So with all that said, let's get started. So to actually input a function that you either want to differentiate or integrate, you would have to use a user interface, which is what this is for. So I'm going to go by each button one by one and explain what it does. So for the first button, this is the clear all button. So if you push it, it would simply clear the entire display. But it's already cleared for now. The next button is the integrate or differentiate button. So if it's on, it would be integrating. And if it's off, it would be differentiating. So right now it's off, so it's differentiating. The next section is the term selector. So if each term has its own ID, so the first term would be 001, the second would be 010, the third would be 011, and the fourth would be 100. So if you want to select just say the second term, then you would type in 010 and then click go to term, and that will allow you to edit that specific term. The next is the numerator and the denominator. So this allows you to input any value into the numerator. That's 7-bit, and same thing for the denominator. This button right here is just going to be the positive or negative for the main term. So if it's on, then that would be positive, and if it's off, that would be negative. So right now it's on, so it's positive. And this button right here is the write to term. So whatever you have selected in here and whichever is in the term selector, if you click that button, it would save into the register so it can be calculated by the ALU. The next is the exponent. So if, let's just say you want something to the x cubed, that you would type in 0011, which is 3 in binary. So this would show up a 3 in the exponent. This button right here is simply just the positive or negative exponent. The next button is the mode selector. So if it's on, it would calculate whichever is in the registers, or if it's off, then it's in editing mode, which means you can change any of the terms and it won't calculate it. And this is just to make it not as laggy when you're putting in the values. Alright, let's just say we want to differentiate the function x to the 4th plus 4x cubed plus 7x squared plus 17x. So the first thing we would do is we would want to select the first term. So to do that, we would click 001 to go to the first term and just click go to term. So now we would want to input 1 over 1 in the numerator and denominator, which is just 1. And we will want to do x to the 4th, so we want to input a 4 in the exponent. And we would also want it to be positive and the main term to be positive. So once we have that, we have our first term, and we can just click save to term, and this will just save it to the registers. It can be calculated by the ALU. Alright, and now we can go on to the next term. So we would type in the term selector, we would do 010, click go to term, and now we want to input a 4x cubed. So we want to put a 4 in the numerator and a 3 in the exponent, and just leave the denominator the same because it's just a 1. So we would do that. So 0011 is a 3 in the exponent, which is a 3, and we would want a 4 in the numerator. There we go. And now it should show up as a 4 in the numerator. And then we would just click write to term. And you just do that for each term. So I'm going to be right back and plug in the final two values. Alright, now that I've inputted the rest of the function, we can now click the calculate button. So now it's in edit mode, so if we push this button, it's in calculate mode, which means it will now calculate the derivative of this function. As you can see, it's calculating, and that is the derivative, 4x cubed plus 12x squared plus 14x plus 17. But let's just say you want to find the integral of this function. All you would do is you would click this button to integrate the function. Then you should see a integral symbol, a dx, and a plus c pop up, and it should start calculating the integral of the polynomial function, and it is done. So 1 over 5x to the 5th plus x to the 4th plus 7 over 3x cubed plus 17 over 2x squared plus c is the integral of that function. Alright, now that we went over how to input functions to the calculator, I'm going to go over the mathematics side of things, so going over what a derivative is and what an integral is and all that stuff. So for the people that just came to see the Redstone, I'm going to leave a time code on the screen so you can just skip to that, and I should be going over how the Redstone works. Now that we know how to plug in a function to the calculator, let's talk about what a derivative even is in the first place. So a derivative is defined as the amount by which a function is changing at one given point. So what that means is, given a point, what is the rate of change of that point? So let's just take the point 3, 9, which is on the function x squared, f of x is equal to x squared. So if we want to find the rate of change at that point, then we would want to find the tangent line to this point. And the instantaneous rate of change would be the slope of a tangent line. Okay, so a derivative is a function that can tell us the slope of every single point along this curve. So the derivative would be this function right here, this blue function. So if we want, so let's just go back to this tangent line. So the slope of this tangent line is 6, meaning that you rise over 1, so 6 rises 6 and goes over 1. And if we look at the derivative at x is equal to 3, we can see that it's 3 comma 6, and the 6 would be the slope of this tangent line, or the instantaneous rate of change at that point. And we can change this to basically, and this works for every single point along this curve. So at point 1, 2, or 1, 1, the slope is, or the instantaneous rate of change is 2, because the derivative is 2. If we hover over it, oh, basically, yeah, hold on. Yeah, 1 comma 2. So the slope of a tangent line at 1 comma 1 of x squared would be 2, because the derivative is 2 at x is equal to 1. Now that we know what a derivative is, let's talk about how we would actually calculate a derivative. So for this, we would use something called the power rule. The power rule is defined as the derivative of x to the n is equal to n times x to the n minus 1. So if we want to differentiate the function x to the 4th plus 4x cubed plus 7x squared plus 17x, we want to differentiate each term individually and apply the power rule. So for x to the 4th, it would be 4 times x to the 4 minus 1, which would be 4x cubed, because you would subtract 1 from the exponent. You would do that for each term until you're left with 4x cubed plus 12x squared plus 14x plus 17, which is the derivative of the original function. Okay, let's talk about what else the calculator can do, and that is finding an integral of a function. So an integral just relates to finding the area under a curve. So right here we have the function f of x is equal to x squared. And let's just say we want to find the area from 0 to 4. What we could do is find the integral, or just find a function that, given a x value, it will give us the area under this curve. And in this case, f of x equal to x squared, the integral is x cubed over 3. And if we want to find the area from 0 to 4, we would just look at the x value of the integral and see that it's 4 comma 21.3, meaning that the area under from 0 to 4 of x squared is 21.3, and this works for any area under this curve. And that's basically what an integral is. And in a few moments, I'm going to show you how you would actually find an integral of any polynomial function. Now that we know what an integral is, let's go over how we calculate it. So we use the power rule from before, except we use the inverse of it, meaning that instead of multiplying and subtracting the exponent, we actually add to the exponent and divide by it. So what this looks like is the integral of x to the n dx is equal to x n to the n plus 1 divided by n plus 1 plus c. Now the plus c is just a constant. So if we want to integral that same function from before, x to the 4th plus 4x cubed plus 7x squared plus 17x dx, we would integrate each term and then apply the power rule, or the power rule for integration. So x to the 4th would become x to the 4 plus 1 divided by 4 plus 1, which is x to the 5th divided by 5. You do that for each term, so you should get x to the 5th plus over 5 plus x to the 4th plus 7x cubed over 3 plus 17x squared over 2 plus c. And that plus c is just a constant, and so that function at the bottom is the integral of the original function. Alright, now that we know how to calculate a derivative and integral, let's look at the redstoning behind this. So if you've noticed, you can see that there is, since we have 4 terms, there is 4 different display segments, ALUs, and busing. So it's basically the same thing, but just 4 terms. So let's just look at one term and go over how it works. So this is one term of the calculator. You can see it has its 10 7-segment displays over here. It's busing, or its input, so this is where the signal would go to input the values into the register, and the ALU, so basically the adders and multipliers that actually do the power rule. And the output of this just goes into the bottom display over here. So that's basically in a nutshell how it works. Now I'm going to get into like the details of how you would actually input a value. Alright, so this is basically how you would input a value with this thing. So this is the primary busing segment, which goes through each term. It has 2 outputs, one to the top display segment and another to the ALU, which would then be processed to the bottom display segment. So I'm basically going to be showing what each of these buttons do. So I'm going to start with the top one. So this is the differentiation or integration button. If it's on, then you're integrating, and if it's off, it would be differentiating. So if I turn this on, nothing will happen because it's not hooked up to the ALU. But if it was, it would integrate whichever is in outputting in their registers. Alright, and then this 3 levers right here is the ID, which I mentioned at the beginning of the video. Basically, it's a decoder which goes through, and if it's selected, then this would turn off. But if it's any other 3-bit value, this would turn off, basically. So right now it's off. So if it's just 0, 0, 0, it would turn on, and now it's not selected. But if it was selected, which is 0, 1, 0, then this term would be selected, and you could input any value you wanted to into this, and which would then be calculated. This next segment right here is the exponent. So if you wanted to input like x cubed, you would put the 3 right here, because the cubed, and this is just a positive. So if it's on, it'd be positive. If it's off, it'd be negative. This 7 bits right here is the numerator value. So if you want to input like a 12 to the numerator, or a 13, you do 1, 1, 0, 1. And same thing down here, but except this is the denominator. And as for these two, this is the right switch. So if it's selected and you click this button, it will write whichever is in here into the registers, which is over here. Alright, and then this right here is just the main term is positive or negative. So if it's on, it'd be positive. If it's off, it'd be negative. And as for these two right here, this is just an AND gate to the registers. So if this is off, then nothing can get through to the ALU. But if it's on, then it would be calculated, or it would let the output of the registers go through the ALU. And this is just the write to all button. So if you push this button, it will write any term to all the registers. And let's give an example. So let's just say you want to input the value x cubed, or a 2x cubed. We would turn these on because we want it to be positive, and we want it to be x cubed, which so 1, 1. We would also select the second term because this is the second term. We would want a 2 in the numerator and a 1 in the denominator, and we would also want it to be positive. And then we would just click the right button. So it should output a 2 to the numerator and 1 to the denominator, and this is just a positive or negative. And a 3 to the exponent, and this is just a positive or negative. So if it's on, it'd be positive. And it would be also inputting to the ALU. So a 2 and then a 1, and then this would just signify that it's positive. And same thing over here. So yeah, also one thing to note, as long as you have it selected, anything you input here will go into the display. So if I just turn this to 6, it will go up here. It will actually display 6 in the top display segment. So yeah, that's basically how it works. Let's move on to the ALU. So this is the ALU of the calculator. It basically does all the multiplication and addition for the exponent, numerator, and denominator, and all that stuff. So let's just go back to the example we had, which was 2x cubed. So so we have our 2 right here in the denominator, or numerator, and then a 1 in the denominator, and of course a 3 in the exponent, and that is positive as well as right here. So how does it actually work? So it uses the power rule, as I explained before, and all it does is it takes the signal, and the signal from the exponent, it gets multiplied to the signal from the numerator. So that 3 goes into multiplier right here, there, and the 2 goes into the multiplier right here, and goes into this massive multiplier, and then gets outputs as a 6, which goes into the numerator. And then as for the denominator, it just gets passed through, like doesn't really get touched at all, and just outputs a 1. And then this gets subtracted by this circuit right here, by just turning this adder into a subtractor, and outputs a 2. So the derivative of 2x cubed is 6x squared, because the 6, and then this is just the squared, and it's all divided by 1. But let's just say we want to integrate that. What we would do is just flip these two switches, which would just turn it to integrate. And instead of just going straight into the multiplier, we would actually have to add 1 and then go into multiplier. Before, we just went into the multiplier without adding 1. But when you're integrating, you have to actually add 1 and then do the multiplication. And in this case, it would just be multiplying with the denominator, and the numerator would just simply pass by. So we have a 4 in the exponent, a 2 in the numerator, and a 4 in the denominator, and it's positive. So yeah, so basically the most complicated part of the ALU is just the multiplication. That's everything else is kind of simple, well, relatively simple. So yeah, let's go over this massive segment right here, which is the multiplier. So this is the multiplier. Right now it is multiplying 2 by 3 to output 6. And to really understand how this works, you have to actually understand how binary multiplication works. So down here, I basically drew out basically how it works. So if we want to multiply like 2 by 3 in binary, we would multiply each term and get a partial product and just sum those up to get 6. So you've probably done this in school, and like elementary school. So you would just multiply the 1 by the 0 to get 0, 1 by 1 to get 1, and of course keep doing that. And then when you get to the second term, right this one right here, you would add a 0 and then start doing it. So 1 by 0 is 0, and then 1 times 1 is 1, and then you would just add it up. So you would just add 0 by 0 by 0, which is 0, 1 times, or 1 plus 0 plus 0, which is 1, and then 0 plus 1 plus 0 is 1, and then you would finally get 6. So 2 times 3 is 6. And which is, so you would basically AND each term. So if you want to see if it's a 1, you would just AND it. So this is basically just an AND gate, and that is what this does right here. And by the way, full disclosure, this design right here is by Noah Master. He also does Redstone calculators and stuff like that. Alright, so basically how it works is if you want to multiply, like, let's just say 5 times 5. Let's just do that. Right, you would sum up each row. So this basically creates your partial product. So this tiny thing right here creates the partial product, and everything else, this onward is just adders, which I'll show the layout of my adders in a moment. So if we add 16 plus 8, so there's 1 plus 1, so that'd be 8 plus 1, we would get 25. And we would just sum up each row. And to do that, let me just plug in 5 by 5 again. So this is the layout I have my adders in. So these yellow blocks right here, just pretend they're adders. Alright, so the 1 would just pass by, because you don't really need an adder for that. The 4 would get added, and this would also get added, and then it would carry over right there, and then the what is this, 16? Sorry, yeah, the 16 would just get passed through. So yeah, that's basically the layout I have my adders in. So if we plug in, so let's just plug in 5 times 5 into this calculator just to show that it works. Right here, we get 16 plus 8 plus 1, which is 25. And if we just go over here and just sort of trace where the signal would go, we would get 1, and then this would be 4 plus 4 would go into here, basically 1 plus 1, and then that would go into the carry. This would be 8, and then the 16 would just go through here. So it'd be 1, 1, 0, 0, 1. and that's basically it. You would just basically replace each one of these yellow things with adders, and basically what I did right here, and you would have your multiplier. So that's basically how the multiplication works. Alright, let's talk a little bit about the display segment of the calculator. So this is just one segment of the display unit, and to display a value, you simply input a binary value and it will output a decimal in the 7-segment display right there. So if we just want to input the number 17, we would just put 17 in binary, which is just 10001. It will go through the machine and output 17 in decimal. That's basically the functionality of the display. Now, it's broken down into 2 segments, the binary to BCD segment and the display segment. Let's talk a little bit about the display segment, which is over here. Alright, so how this works is that it decodes a binary value into one of these 10 lines right here, so 0 through 9. So right now, 0 is being displayed, so 0 is being decoded because there's nothing in here, but if we change this to like a 1 in binary, it will show 1 right here. So each one of these correspond to a digit, so 0 through 9. So if we go to number 5, then the 5th one will be off. And how it actually shows a number is with these torches right here. So when the line is on, which is most of the time, the torches will turn off, meaning that nothing will get sent down these lines. But when it's off, meaning that a number is selected, we'll just go to 0 for now, then these torches will turn on, which will then go through this line right here and into the display, meaning that it will actually retract the pistons and show the number. So it is the torches in right here that actually give the actual number in 7 segments. So if we just go to give another example like 5, then this torch is on, but if we were to, let's just say, break this torch, then this top one would turn off. And that's basically how it works, just torches and decoders. And over here is just the same thing, just stacked really close next to each other. Alright, so this is the binary coded decimal converter used in the display unit. So it uses a binary value as the input. So let's just say we want to input the value 17, and it would output a binary coded decimal of that number. So it would output a 1 in the tens place and a 7 in the ones place. And the places are divided by these by this gold block. So if we just take the number 64 and just put it over here, then it would output a 6 in binary in the tens place and a 4 in binary in the ones place. So to understand how this works, I made a little diagram of it's the same layout as this, the same sort of layout, and so let's just go over one of these modules and like what these do. So I have one over here. So this uses something called the double dabble algorithm. So it basically states if the input of this module is greater than 4, then you add 3. So if we have, let's just say the input 5, then this would is greater than 4, so you would add 3 to output 8. But if it's just 4, then 4 is not greater than 4, and it would just pass through. And same thing for any number lower than 4. So that's basically how one of these modules work. Now if we take this and apply it in this pattern, if we plug in 64, to this module it sees a 2, so it would just pass through. To this module it sees a 4, so it would pass through. To this module it sees a 8, so it would add 3 and output 11 in binary, which is 1, 0, 1, 1. And if we go to this module, it sees a 1, so it would pass through. And if we go to this module, it would see 6, so it would add 3 and output 9, which is 1, 0, 0, 1 in binary. This would say a 3 in binary, so it would just pass through. And this would say a 2, and this would pass through. And what we're left with is the binary coded decimal of that value. So in this case, 64. So this is 1 or 0, 1, 1, 0 in binary, which is 6, and 0, 1, 0, 0, which is 4. So 64. And this works for any binary value. And this is in the same layout as this. So that's basically how the binary to BCD converter works. Alright, now that I've gone over how the ALU segment works, the busing segment works, and how the display segment works, I'm going to go over how the entire calculator works, like overall in a nutshell, really fast. So, given that the ID switch is enabled and the calculator switch is on, and you push this button, it will write all the values into the registers, which then be processed by the ALU, and given if the switch is on or off. If it's off, it would differentiate, which means you would multiply the term by the exponent and subtract the exponent by 1. If you're integrating, you would add the exponent by 1 and divide the term by the exponent. The output of that will then go over here into the BCD converter, which will then use the double algorithm, and then it would output it into the 7-segment display, which would then be shown to the user. That's basically how the calculator works in a nutshell. Alright, that's about it. Hopefully I explained everything well. If you have any questions, be sure to leave a comment. I'll try and respond. I'll also leave a world download so you guys can plug in functions and see how it works. And that's about it. Thank you guys so much for watching.